Hi there. Let's take a look at the derivative of inverse functions. But before we get there, we need to refresh our memory a little bit about how inverses work. I know you've probably learned this in the past, but for some reason, when we try to take the derivative of the inverse, all of those rules that we knew about inverses, or maybe those characteristics, those relationships, are very, very important. So I thought we'd review it just a little bit. So when we look at the function f of x, the inverse, and you'll remember the notation we use for the inverse of f of x, is numerically defined to be the function whose range is the domain of f of x and whose domain is the range. Now, you may remember that maybe you learned when you did an inverse that you switch x and y. You switch the domain and range between the function and the inverse. That's essentially what this statement is saying. Now, graphical representation. So if we're looking at a function, if we're looking at the graph, how do we know if two things are inverses? They are reflections about the line y equals x. Meaning that if you drew the line y equals x and you folded about that line, you're going to get mirror images on both sides. The function being on one side, the inverse being on another, and you're going to get that mirror image on both sides of that line y equals x. Now, if we try to analytically represent the inverse, then what we find is that the function of the inverse of x gives us x, and the inverse of the function of x also gives us x. That one we use when we're given the equations for the function and the inverse. I want to look first of all primarily at the numerical data. So we're going to look at how do I do this from a chart first of all. Um, and so I think it's wise for us to go ahead and write out a chart for the inverse of f. Now remember, we talked about switching x and y, switching the domain and range. So when you look at the chart for x and f of x, when you do the inverse, you're going to simply switch those. So instead of -2, 3, you're going to have 3, -2. See how I switch those? Instead of 1, 2, you're going to have 2, 1. Now the same is true for g of x. So instead of -2, 1, I'm going to have 1, -2. Instead of 1, -2, I'm going to have -2, 1. Pretty simple. All I did was switch the x and the y there. Now, for these next few, I want you to be very intentional about focusing on what chart we need. Okay, so let's begin this f of g inverse of -2. Now, you'll remember we start on the very inside of that expression. So I'm going to start with g inverse of -2. So that means I'm going to the inverse g chart. I'm going to look for -2, and that gives me 1. Okay, so I'm going to replace g inverse of -2 with a 1. Now I need to go to the f chart, which is up here, when x is 1. That gives me 2. So 2 is my final answer there. Remember, it's all about which chart are you supposed to look at, making sure that we look at that chart. Let's do this next one here, the inverse of f of the function of f of 1. Again, starting in the middle there, on the inside, f of 1. Let's go to the chart that has f. When x is 1, we get 2. So I'm going to replace this f of 1 with a 2. Now I'm going to look for the inverse of f of 2. So go to your inverse of f chart, look for when x is 2, and that gives you 1. Okay, let's look at the inverse of g of the inverse of f of 2. Start on the inside, the inverse of f of 2. Go to your f inverse chart. When x is 2, you get 1. So I get the g inverse of 1. Now go to your g inverse chart. When x is 1, we get -2. Are you getting the hang of it now? Looking at the right chart is so important. Now we're going to do 3 of them. Okay, let's go in order from the inside. The inverse of g chart of 1, that gives me -2. So now I have the inverse of f of g of -2. Okay, next let's go to g of -2. So I'm going back to the g chart. When x is -2, g is 1. So I'm going to replace that with a 1. Now I've got f inverse of 1. Go to your f inverse chart, which is here. When x is 1, oh no, we don't have when x is 1. When this happens, and I'm going to be honest with you, it happens with inverses, then we say it is undefined. Be real careful. It's not no solution. It's not 0. It's undefined because we don't have a value for when the inverse of f of 1. Okay, I want to point out we haven't done any calculus at this point. Okay, we've only reviewed things about inverses. Let's take a look at some calculus then. All right, when we're looking at the calculus part, we want to find the derivative of an inverse. So what we do is we use that analytical relationship between a function and its inverse here. And I'm going to use the chain rule. I'm going to take the derivative of both sides here. The chain rule is going to be needed on the left side because I see an outside function, which is f, and I see an inside function, which is the inverse. So let's take the derivative of the outside. That would be the derivative of f at the inverse of f. That's the derivative of the outside. And then let's do times the derivative of the inside. Well, the inside is the inverse. So we're going to take the derivative of the inverse. Watch, the notation gets a little tricky here. That's the derivative of the inverse. And that equals, now we'll do the derivative of x. Pretty simple. That gives us 1. Now, we want the derivative of the inverse. So I'm going to divide both sides by this expression. So the derivative of the inverse equals 1 divided by the derivative of the function at the inverse. Now, I know that may seem like really crazy, but that's the formula we need. We're going to use it. Okay. So let's look first of all at, we're going to look at it from an equation approach, and then I'm going to look at it from a numerical tabular approach. Okay, suppose that f of x equals 3x plus 2, and we're told the derivative of negative 2 is 3. What is the value of the derivative of the inverse at negative 4? Okay, the first thing you have to realize, this negative 4 is an x value on the inverse. Negative 4 is an x value on the inverse. That means it's a y value on the function. Let me say that again. Very important connection. This negative 4 is an x value on the inverse, which means it must be a y value on the function. Now, if we can make that connection, then what I'm going to do is replace this function, this y, with a negative 4 so I can solve for x. Okay, now pretty easy. You can see where x is going to be negative 2. That's pretty easy. So negative 2, negative 4 is on the function, which means negative 4, negative 2 is on the inverse. We have to make that connection. Okay, now let's deal with the derivative, because here's what it says. What is the derivative of the inverse of negative 4? Okay, so I want the derivative of the inverse of negative 4. And my rule says I do 1 over the derivative of the function at the inverse of negative 4. Okay, go on the inside. What is the inverse of negative 4? Go to your inverse. What's the inverse of negative 4? That is negative 2. So I've got 1 over the derivative of the function at negative 2. Do you see what I did there? I replaced the inverse of negative 4 with negative 2. Now, the beauty of the rest of this is the inverse of negative 2, the derivative of negative 2, we were told is 3. So this equals 1/3. Now, I know that seems a little bit, that was a lot of connections to get to that. I will be honest with you, that is not how we see it asked mostly on the AP exam. We tend to see it asked more with the table. So let's look at the table then next. I've got this humongous table, a lot of values there, so I'm going to go real slow when I look through that. I'm looking for the value of the derivative of the inverse of f at 3. Now, what I like to do, because my table only has the function and the derivative, I go ahead and make a table for the inverse of f. It just makes me feel a little bit better, makes everything a little easier. So I'm going to take my x's and my function of f, and I'm going to switch them, just like we did at the beginning of the lesson. Switching my x's and my y's. All right. So now when I want to find the derivative of the inverse of 3, I know it's 1 over the function at the inverse of 3. Okay. Now, go on the very inside, just like we've been doing. The inverse of f at 3 comes from your inverse chart. And the inverse of 3 is 1. So I know now I'm doing 1 over the function at 1. Now this value, you'll have to go to the original chart when x is 1, and we're going to the derivative, which is 2. So I end up with 1/2 here. Okay, let's do the same thing for the next one. I think it's a value to go ahead and make the chart for the inverse of g. That's what I do. So I'm going to make a chart for the inverse of g. Again, I am switching the x values and the g of x values. Just switching them. All right, now if I want to find the derivative of the inverse of g of -2, boy, is that a mouthful, huh? I know I'll do 1 over the derivative of the function of g at the inverse of g of -2. Okay, again, on the very inside, that g inverse of -2. Go to your g inverse chart, look at when x is -2, and that's 1. So you're really looking for 1 over g prime of 1. Go to your original chart when x is 1. And this time we're going to g prime, which is 1. So I end up with 1 over 1, oops, which is 1. So it takes a little bit of being intentional with our charts, but you can do this. You definitely can find the derivatives here. Okay, let's use our last few examples to practice with. Got a nice chart again. Looks to be the same chart. So this time we're going to go a step further. We're going to find the derivative of the inverse of g of 1. Then we'll find the equation of the tangent line, of the inverse when x is 1. Okay, so let's make our g inverse chart one more time since it's not on this page. We have it on the other one, but we want it to be handy, so we'll go ahead and do it again. Let's switch the x and the g values so that we get our inverse. Okay, let's find our derivative. We want the derivative of the inverse of 1, which would be 1 over the derivative of the function at the inverse of g of 1. Go on the very inside, the inverse of g of 1, go to your inverse chart. When x is 1, we get 3. So we're really finding 1 over g prime of 3. Go to your original chart this time. When x is 3, we need the derivative of g, which is -2. So I end up with -1/2 for the derivative of my inverse of 1. Now remember, that is going to be the slope of your tangent line you need here. Next, we need a point. And remember, this point is on the graph of the inverse. So you're going back to your chart with the inverse. And when x is 1, we get 3. So we have this point 1, 3. See how much nicer it is once you have that table for the inverse already written. Makes it so much easier. Now you have your point, you have your slope. You can write your equation of your tangent line. Y minus 3 equals negative 1/2 x minus 1. And there you go. Super, super easy, right? All right, let's look at our next one. It says to estimate, which means we're not going to find it exactly, estimate the value of the derivative at -1. And then once we do that, what conclusions can we make? So if we can't get the derivative exactly, we have to know that derivative means slope. Well, if derivative means slope, is there another way we can do slope at -1? And the answer is yes. We can do slope the algebra way. And I put these just to mean approximately. So let's do the slope around -1. See, we have some really nice values of 0 and 2. But in order to do slope the algebra way, you have to remember your y2 minus y1 over x2 minus x1. So let's do the y value at 0 minus the y value at -2. I'm just using function notation instead of y value over 0 minus -2. Now these values are going to come from your chart. So g of 0, go to your chart. When x is 0, g is -3. When x is -2, g is 2. And on the bottom, we've got 0 plus 2, which is just 2. And so we get that g prime of -1 is about, it's not exact, but it's about -5/2. Not exact, but about. All right. So it says, based on this value, what conclusions can be reached about the function? If we know that the derivative came out to be about -5/2, notice it's negative. When the derivative is negative, we can always say that the function is decreasing. So g of x is decreasing at x equals -1 because g prime of -1 is negative. Feel free to use the DEC and the NEG for your abbreviating your words there. Don't feel like you have to spell those correctly, but you do need all of the parts of this statement here. You need to tell us the function is decreasing at this value because, and that's going to take care of your explain your reasoning part. Really, really get into the practice of that so that you will be ready for it when you're looking, when you're answering on your AP exam. Okay. The last one for this lesson, ask us to estimate the value of g double prime of -1. G double prime of -1. Now, again, in the same way that we were able to do the slope the algebra way to find the derivative, we can do a similar approach for the second derivative. We can say that g double prime is about, and this time, watch the y values I'm going to use. I'm going to use the y values of the derivative. Ooh, that's tricky. We haven't done that before. Okay. But in the same way I did with the function, I'm sorry, I use the function y values to get an estimate for the slope of the slope, which would be the derivative. I can use the y values of the derivative to get an estimate for the second derivative. Okay, again, I need those values from the chart. So let me pull them back down here. When x is 0, g prime is 2. When x is -2, g prime is 3. And then on the bottom, I've got 0 minus -2, which is 2. So I've got -1/2 for G double prime at -1. Okay. So when second derivative is negative, we know that the function, because notice we're being asked for, oh, what do we know about the graph of G prime? Oh, this is good. Okay. If the second derivative is negative, then the first derivative, it's the same relationship, G prime of X is decreasing at X equals -1 because G double prime of -1 is negative. It's the same relationship. You had the same relationship between the second derivative and the first derivative that you had between the first derivative and the function. So I hope that helps. I really like this inverse approach, but also we're bringing in some good questions that come from tables. So we'll keep working at it. If you have any questions or comments, please feel free to leave them in the comments below. I'd be glad to address any of them. Bye for now.